What is up, Flutter devs? Today we figure out how to set individual pixel colors as well as regions of pixel colors. This will hopefully round out our bitmap and pixel intensive work, allowing us to go do some interesting coding challenges after this, but we have to get this final part in, so let's go take a look at these APIs. Here under the pixels subheader, you'll see loadPixels, this pixels array, set, and updatePixels. These are all very closely related, and we're going to need to deal with all of them today, except I'm not going to provide public access to a pixels array. That won't prevent any relevant capabilities, but because we need to go through Flutter and Dart's concept of images and bitmaps, this concept of a pixels array doesn't quite make sense in our case. But the concept of it still matters. So all of this begins with loadPixels. What loadPixels does is it essentially takes a snapshot of whatever is currently painted to your sketch, and it puts all of that pixel data aside in this array or buffer called pixels. That then allows you to set pixels in this buffer, and whenever you're ready, you can paint it back to the screen. This particular example doesn't do much of interest, but let's take a look at what is going on here. First, an apple's image is loaded and it's painted at the top left corner. I don't know what the size of that apple's image is. Let's assume it takes up the entire canvas. But then they call loadPixels. What does that do? It takes a snapshot of the screen, of the sketch, and puts it aside into an independent array of pixels. Then there's this loop, a loop through half the image, apparently. Half the image was calculated up here. Remember, these are pixel indices. So width times height divided by 2, that is halfway through the image going pixel by pixel by pixel. At every pixel in the buffer, well, okay, we're copying part of pixels to other part of pixels in this buffer, but what we're doing is we're taking so we're taking every pixel plus half an image, and we are setting it equal to the pixel on the top half of the image, essentially. I represents all the pixels in the top half of the image, and for every one of those, which is right here on the right, we are copying it to a similar location on the bottom half of the pixels buffer. Now that in and of itself does not do anything visually. It's this updatePixels call that takes the pixels array and actually paints it to the screen. Now we've already accomplished this particular task without using the pixels array. You'll recall here that we copied the top left corner of this image down to the bottom right. So you don't need the pixels array to do this particular effect, but that's what they're using here in this example. Before you read or write any pixel values using this pixels array, you must call loadPixels. And whenever you want to see a change on the screen, you must call updatePixels. Now, again, I said I'm not going to provide direct access to the pixels array. Instead, we are going to implement the set method. In fact, down here, you'll see it says, setting the color of a single pixel with set XY is easy, but not as fast as putting the data directly into pixels. Once everything is said and done, I'm not sure there will be a difference in speed for us because we have to do additional manipulation of the byte data. So I'm just not going to worry about that for now. We can provide this pixels array later if it turns out to be something that's nice to have. But the point is that if you call set with an X and a Y and a color, it's the same thing as going into the pixels array directly and setting a color. Same thing. But this set method, well, so real quick recap, that covers all three pieces, right? You call loadPixels, then you call set on some number of pixels, and then you call updatePixels. That's everything we're trying to deal with here today. But set is not just a method for one pixel color. You can pass an image and set a whole bunch of pixels. P image to copy into the original image. Now, P image is not what we're using. We're using Dart and Flutter images, but same concept. So the first thing that we need to do is go implement loadPixels to take a snapshot of the screen. And fortunately, there won't be a whole lot to that given the capabilities that we already have. So here we are back in Core. And last time, if you'll recall, we implemented the ability to get a pixel color and the ability to get an entire region of pixels as an image. And we also had to implement some intermediate rasterization to make that work. So now let's come down here and let's say future void load pixels. Load pixels does not return the pixels. It loads the pixels into a local member. In this case, it's going to be a hidden variable. And this will be async. Now, load pixels copies whatever is on the screen. But because we're using canvas operations, just like in the previous video, what do we have to do first? Well, we have to do intermediate rasterization. If there are any canvas operations, we need to go ahead and paint those to a bitmap so that we can copy the bitmap. And then we need to figure out which image we're going to copy. Either we're going to copy the intermediate image. If there were any canvas operations at all, the intermediate image is what we're going to use. But what if there were no canvas operations yet? Well, in that case, we're going to use our published image. Now, we're going to create a thing called pixels privately. It doesn't exist yet, but we're going to set it equal to the source image to byte data. That's going to fill up our pixels array. It's not really an array. It's a byte buffer or something here, or byte data. It's a byte data, but that means it's full of byte data, which is close enough. So now we just need to make sure this pixels thing exists. And we'll put that up near the top. Too far. We'll put that up near our other bitmap stuff. Published image. Where are you? Here you are. We will say byte data optional pixels. Okay, so in theory, that will load pixels. Let's at least make sure that doesn't crash anything. Here's what we're running again, okay? We'll open up that sketch, and we'll just go to the bottom and call load pixels. And there we go. So no visual change, that's fine, we didn't expect one. We don't know for sure yet if loadPixels is working, but we know that it's not crashing. Let's jump right in and do the opposite side of loadPixels, which is updatePixels. Now, if pixels is null, we're going to throw an exception. So now we know it exists. And look, what's our goal here? We want to take pixels and apply them to the screen. We want to paint the pixels back to the screen. Okay, well, let's start by getting a codec like we've done a number of times before. We'll create a pixels codec. We'll start with an image descriptor, raw. we know that we need to give it an immutable buffer. We'll go from a uint8 list. We'll take pixels buffer as uint8 list. And the width should be the same as the overall width. The overall width of the sketch, that is. Same thing for the height. And the pixel format, we will say RGBA. And then we want to instantiate the codec. But then we need to actually get the Dart/Flutter image for that so we can paint it. We need the pixel image, which is await pixels codec get next frame dot image. And then we're going to just draw that image. To the canvas. Okay, so we decode it, we get the image object, and then we just run the normal operation to paint it. Let's save that. And after we load pixels, let's go right ahead and update pixels. Now, we don't expect any difference here, but in theory, everything we're seeing is being copied and immediately painted back to the sketch every frame. In fact, one thing that we can do, let's say s dot fill we're going to make it red, and then circle offset s dot width over 2, s dot height over 2, diameter 100. All right, we have a big red circle in the center. Now, what if we take that red circle and we put it in between these two calls? Now it's gone. Why is it gone? It's gone because we take a snapshot of the screen before we draw the circle, then we draw the circle, but then we go back and paint the screen as it was before the circle. So this is a pretty good indication that we are both loading and updating pixels the way that we think we are. Okay. That leaves us with set and set region. So we need to be able to set a pixel color, and we need to be able to set a region of pixels. Now, I guess if we can find a pixel right up around here somewhere, maybe we can just set that with a green color or something and notice that. It's going to be kind of tough to see one pixel. Maybe we can remove the images. Whatever. We'll see what we can do. So in between here, we're going to have set, and set is going to require an X, require a Y, and require a color. We're going to copy this exception condition. It's up to the developer to call loadPixels before calling set, otherwise they're going to get an exception. Now, what is the index of this pixel within the pixels array or buffer? Pixel index, remember the get bitmap pixel offset from the last video? The image width is the width of the sketch. The X value is what we're given. The Y value is what we're given. That's the pixel index. And then we say pixels set uint32 at pixel index with color dot value. Now, I think I was playing with this previously, and I expected this not to work correctly, because this color value is not in the correct byte order. But then somehow it did end up working out correctly. So let's see what happens here. We'll come back into main. We will say between the load and the update, we will say s.set x. I don't know. We want something like maybe 100, 50. 100, 50. And we'll go a color. Let's start with red. If it's there, I can't see it, and I don't know if we're going to be able to see it. So let me take these images out of here. Let's see, do we... Okay, I don't know. There's something there maybe, or is it just my screen? Looks like there's something right there, right? Let's draw this magnifier after we set the pixel. I'm not sure if I'm getting on top of that little pixel there or not. Okay, let's see what we can do about this. Let's do the color transformation that I thought we were going to have to do and see if that makes any difference. ARGB color int equals color.value. And we're going to need to do this in two pieces. So we want to push the alpha back. So we want to take ARGB color int and we want to mask it with the alpha part. And then we want to take the resulting alpha value, and we want to push it, I think it's 24 bits that way. And then we're going to take the ARGB color int, we're going to mask it with the color part. And we're going to move it 8 bits to the left. And let's see what happens when we pass the RGBA color in there. Well, now I think it's gone. So maybe that wasn't right after all. Let's try black instead of red and see if that gives us any difference. No, now I'm not seeing anything. And let's also bring back the stroke. Okay, so we do still have that circle there. Let's put this thing in a more defined location. Let's go width divided by 2. And let's say s.height divided by 2. So there should be something in the middle of the screen there, but I can't see it. Okay. Let's set a bunch of pixels maybe and just see what happens. Okay, well, there's something. It's interesting that it's not being seen as a color. Oh, this is in the wrong place for starters. Okay. Now it's definitely not black. So let's bring back the RGBA color that I did here. Okay, so I don't know what's going on with my experiences with these color transformations, but it turns out that we did need the bit shifting. Now, so every one of those pixels is set 1 pixel at a time, 400 pixels in each direction. And we should be able to make it white as well. How about something like green? Yeah. Okay, so we can set a single pixel. Now, how about an entire region? At first, it kind of seems, so again, a region, it's not a region of the same color. It's essentially copying an image into the pixels buffer. And at first, that might just sound like invoking the image method. But remember, it's not going to the display, it's going to the pixel buffer, which is only displayed when you call updatePixels. Now, for this method, we want a future void set region required image, and we will not, I think we have default values for X and Y, so we don't require X and Y, although actually, I guess they do always exist because there are defaults. Now, what are we doing here? Once again, we're going to repeat this exception line. And then what we need to turn this image into pixel data so that we can apply it to the pixels buffer. Looking at this again, we could try to very carefully do surgery on a couple byte datas, byte buffers, pixel arrays. But we can actually use a canvas locally right here within this method to combine these images on our behalf. I think let's try that first. It may not be very performant, and if it's not performant, then sometime in the future we can find a different way to accomplish this. But this avoids some tricky pushing of pixel data at various places. So let's begin by we have the underscore pixels variable is byte data, but let's turn that into, let's encode it back into an image. And for that, it's actually going to be this exact same thing right here. So now we're back into an image. And then let's create a picture recorder. And a canvas. Then we're going to draw an image, which is the pixels image. Pixel image at offset. Actually, this offset's going to be 0 because pixels is our overall image. The image we're given goes inside of it somewhere. But now we're going to draw the image that we're given. and we're going to draw it at the desired offset. And we have to say to double because apparently that conversion is just too difficult to happen automatically. I'm going to rename this to pixels image. And I'm going to rename this one down here as well to pixels image. So we draw our existing pixels and then we draw the new image that we're given. But then we need to create a picture by saying picture recorder end recording. And then we have the combined image, which is picture to image, the width and height of the overall sketch. And then finally we set pixels equal to the combined image to byte data. I guess we don't need those outer parentheses. Okay, now let's see, how can we put this to the test? First, let's draw the background image again, but we're not going to draw the sub image. I guess it's fine to fill some pixels. That might add some detail. Let's save that. Okay, now you see in the background we have that image back. Now, what I want to do is, let's see. There's nothing here that I guess we couldn't really do with the get region that we had before. But let's say before we apply any of the individual pixel colors, let's say await S set region. What do we want for that image? Well, up here, let's grab the sub image again, but instead of calling s.image, we will pass it to set region. And let's actually do this after the pixels. So in theory, we will paint the background image, then we will paint the green pixels, and then we'll paint part of the background image on top of the green pixels, because that's what we're calling here with set region. And all of this is not being applied to the display, it's being applied to the pixel buffer, which is then being painted to the display. So let's save that. Yeah, so there it is. Similar to what we were doing before, just using the off-screen pixel buffer instead of directly and immediately applying it to the screen. And you can see that we're still getting the colors that we expect. So I think that was all we were trying to tackle today. We can now copy the display to an off-screen buffer called pixels using loadPixels. We can then set individual pixel colors, which will be very important moving forward. We can also copy an image into the off-screen pixel buffer. And then we can update pixels at the end of that to paint it back to the screen. This essentially gives us we can go mess with the off-screen buffer while things are still happening on the screen. That's the concept here, is that you kind of have a canvas on the screen and you have a canvas off the screen, and then eventually you can paste from or copy from one to the other, that kind of thing. So once again, we're not going to worry about writing tests for this because the testing situation is not allowing us to do a lot of this bitmap stuff very easily. I'll figure that out at some point. But I think in the next video, we will finally get to play with some coding challenges again. So I'll see you then.